There we go. So, hi everybody, I'm Benjamin. I work at Stack Overflow, as you can tell by my uniform. And I'm here to talk to you about programming language design. Specifically, I'm here to talk to you about TypeScript, which is one of the family of programming languages which compiles into JavaScript for execution in the browser. Now, the TypeScript designers made an interesting choice, which was to steal 90% of JavaScript's syntax. The idea being that the TypeScript that you write should be very similar to the JavaScript that gets generated, right? The main thing that TypeScript has added on top of JavaScript is a type system. Now, it's an optional type system. It's what's called a gradually typed system, which means that if you take JavaScript and feed it into TypeScript, it will work automatically. The type checker is off by default, but it allows you to opt into static typing to the extent that you want it by adding type annotations. Now, I'm going to spend the next 10 minutes or so complaining about TypeScript, showing you a way in which it's broken. So I feel like I should say at the start that I like TypeScript. We're using it reasonably extensively at Stack Overflow now. It makes working with large JavaScript code bases a ton easier, just because you've got a tool to check the well-formedness of your code. So anyway, I'm going to show you a program which tricks the TypeScript type checker into believing a false fact about your system. It's going to think that a variable is one type, whereas in reality it has another type. So I'm going to switch to some code. Right, so we've got these couple of classes here, right? We've got a class for registered users who we know who they are, and we've got then their actual name, and we've got a class for anonymous users for which we've only got a number or whatever. And down here, I'm using what's called a union type. Now, a union type is like OR for types, right? So what I'm saying is, if I've got something of type user, it could either be a registered user or an anonymous user. Everyone follow so far? Now, since these two classes don't share any common structure, the only thing, if I have something of type user, the only way I can do something with it is by performing some sort of runtime type test, right? So here I'm using the JavaScript instance of test to check the type of this U variable, right? This U variable here. And TypeScript has done something quite interesting here, which is that after performing the instance of check, it has adjusted the type of U. So the point is, in this branch, I can access the name property, and in this branch, I can access the ID property. If I were to say u.name out here, it would be rejected because we don't know that U is a registered user at this point. This is quite cool, I think. This is quite sort of modern type system design. We're doing a runtime test, and we're learning something about the compile time type of this variable. C# devs have been asking for this for a long time with the is operator. People have been asking, can I say U is registered user and then not have to declare a new variable and cast it, etc. But when I see this feature, I think to myself, well, let's have some fun with it. Can we break it in any way? So my first thought was, well, what if we perform this test and then U changes its type because we assign something to it? So I've done that down here. So I'm testing that U is an anonymous user and accessing the user ID property of that. Then I'm changing U to be a registered user. Now, I was expecting originally that TypeScript would say, it would either say, no, you can't assign a registered user to a variable of type anonymous user, right? So here well, it seems to think that U is a user. But here U is an anonymous user. I shouldn't kind of really be able to assign a registered user to this. But obviously, the TypeScript designers thought that this was a use case they wanted to support, right? So they've done something rather clever. The TypeScript compiler performs quite a sophisticated analysis on my program to see that, well, U is an anonymous user up here, but then after this assignment, U is a registered user. However, it all goes wrong if I perform a rather simple refactoring, assign user, and put this assignment inside a function. Assign user. Right? The TypeScript flow analyzer cannot see inside this assign user function. It doesn't realize that assign user is changing the type of this U variable. So even though this code behaves exactly the same as before, the type checker now rejects it because it thinks that U is still an anonymous user. So this is kind of an opportunity to disguise a bug in your program, right? You think a variable has a certain type, and then it gets mutated somewhere far away, and then you're left in the Chrome debugger thinking, well, the type checker told me it was this type of thing, and now it seems to be something else. How on earth did that happen? So this is a problem. If we were thinking as the TypeScript designers for a minute, how could we solve this problem? Well, there are a few options. The first option would be to say, well, it's kind of weird to have this behavior of the variable changing its type during the execution of the program, right? If we compare it to the way the future version of C#, C#7 does it, it requires you to declare a new variable with the smaller type and leave the old variable as it was, right? The problem with this idea of removing this type refinement idea is that it already exists, right? When you have backwards compatibility to reckon with as a programming language, you can't just unship features willy-nilly because there's code in the wild that depends upon this type refinement idea. So rejecting this idea, another option would be to add some even smarter logic to the type checker, right? The idea is the problem was that the type checker couldn't see inside that assign user function. So how can we attack the problem of allowing it to see inside the assign user function? Well, it's a 2017 problem, but we can go back to the 1970s to find the fix. And the fix is something called Hoare logic. The idea is that you attach preconditions and postconditions to every statement in your program and scale that up to functions, right? So, for example, the postcondition of this line of code would be that you is a registered user, and the precondition of this line of code would be that you has a name property, right? It was invented by Tony Hoare, who was a very clever man. He invented quicksort. He has his own cautionary tale of language design because he invented null. He calls it his billion-dollar mistake. He estimates the costs of null pointer exceptions to be $1 billion over the 40 years that it's existed, approximately. Anyway, so he was interested in proving things about imperative programs, and he devised this system called Hoare logic. And as I said, the idea is to pair every statement in the program with a precondition and a postcondition. We denote this with these curly braces up here. It's called a Hoare triple. So with a program S, a statement S, with preconditions P and Q, we denote it like this, right? And the way to make it scale up is that if I see two statements in my program sequentially, i.e. the semicolon operator, the postcondition of the first statement has to match the precondition of the second statement, right? This fraction thing here is called an inference rule, a logical inference rule, right? This is a mathematical notation. The way it works, the way you should read it is the thing underneath the fraction, P S semicolon T R, is the conclusion of my logical deduction process, and the things above the fraction are the premises. So what this says is if I see the program S semicolon T, then S semicolon T has precondition P and postcondition R, if S has precondition P, T has postcondition R, and the inner bits match up. Okay? Now, the problem with this idea is that, well, first of all, it's quite difficult to implement a Hoare logic checker in an automated fashion, right, without any input from the user. It's quite hard to synthesize this information inside a type checker. And also, there's some sort of less tractable problems. Like, for example, if I'm passing a function to a event handler, how can I be sure that that function's preconditions are going to hold by the time that the handler's called, right? So it's given that this is quite a big engineering challenge and has some fundamental problems, we should probably reject building a Hoare logic into the TypeScript type checker. So a third option would be to say, well, what's the real cause of this problem, right? We like the idea of type refinement. The problem is that we changed the value that was stored in the u variable, right? Mutability. I guess the message of this slide really is that mutability is something that imposes serious costs on the design of a language, right? There are many desirable features in programming languages that mutability makes a lot more complicated. Unfortunately, immutability is really something that has to be built into the language design from day one, right? It's not something we can just retrospectively add to JavaScript because the equals statement is something that people use quite a lot in JavaScript, I hear, so I'm told. So I suppose, yeah, if you're thinking of designing a pet language, think very carefully before you throw mutation in there. And also, I think every developer should learn to program in an immutable fashion. There are lots of programming languages, obviously, namely functional languages, that encourage and some require an immutable style of programming. And it's a very valuable skill to learn. Okay, fourth attempt at a solution. This is a comment from Anders Heilsberg in the TypeScript GitHub repo on an issue more or less reporting this exact problem, right? And he says, down at the bottom, he says, we could spend an inordinate amount of time doing this analysis and still get it wrong, right? This is a lesson about software engineering in general, right? It's all about trade-offs. He's saying that the complexity of the system that we could envision ourselves building to correct this small problem is staggering, and it's not even that big of a problem, right? It is a problem, but I guess my point is that a feature that works 90% is often better than better than no feature at all, and it's also often better than building a difficult to use or complicated system that works 100%. So yeah, that's kind of it. For a problem, 4 solutions, none of which are particularly satisfactory, and hopefully a lesson in programming language design and software engineering in general. If you're interested in programming languages, etc., then there are several other talks on at this conference that I recommend. So check them out. Thanks very much. Oh, any questions? Any questions? Have I got time for questions? What's the time? Haven't really got time.